So, hello everyone, hello and welcome to this webinar. It's about what's new in yFiles in 2026. The team has been working hard on the new releases and the new features, and we're this short to releasing the first yFiles edition in 2026 with the new features. And today I'm going to show you what's in those releases. My name is Sebastian. I'm the technical lead here at yWorks. I lead the development all around the yFiles libraries, and I'm going to show you what's in the release today. We won't be looking at all of the features in the release, but we're looking at the most important ones. So this is the agenda for today. First, we start by looking at the new layout features. As you know, the layout features are the ones that you will find in all of our library variants. So it's not only in the web version, but also in the desktop variants and so on. So in the first part, we'll be focusing on the new layout features and improvements. The second part is about the features that relate to the view, which don't all relate to all the platforms. Some of these are specific to specifically today for the yFiles for HTML platform, where some of these are WebGL features, so they won't be available in all the platforms, but there's also some features that you will find in the other platforms. And then we're going to take a look at what's in it for developers. What did we change to improve the developer experience, and what new demos are there, and how you can use them in your applications. Finally, in the end, I'll be taking your questions. So in case you have any questions, please type them into the chat, and my colleagues will review them and maybe answer them. And for some of them, we'll also be checking them at the end of the session, and I'll try to answer them live here. So please use the chat for that feature. Okay, here we go. Let's start with the new layout features. One of our most important algorithms in yFiles is the hierarchical layout. It's probably the one that's being used by the majority of our customers. And one of the features of that algorithm is that you can incrementally add elements to an existing diagram. And this has been possible before, but there were some difficult parts and some constraints, and we now improved the algorithm to add more features. Specifically, previously, when you started incrementally adding elements to a diagram, which was using the hierarchical layout, you were able to mark new elements so that they will be inserted incrementally. For the existing elements in the diagram, the code typically used the relative position in the diagram. So within each layer in this diagram over here in the yellow layers, mostly the order between the elements was parsed basically, and then we made sure that the order stayed the same. However, it could result in elements slightly moving, even if it didn't always seem necessary. So that's where we improved the algorithm, and you can now configure it on a per item instance basis. So you can tell the algorithm whether you just are interested in letting it keep the relative order within the layers, which typically results in a very compact placement, or whether you want to use the sketch and you want to actually use constraints between various items, and I'm going to show that to you in a minute, or whether you actually want the exact coordinates exactly as they are right in the existing diagram. And for those cases where you actually instruct the algorithm to basically force it to produce overlaps, where there's no other option than using overlaps, if you constrain it to use certain coordinates, you can now control how that happens and basically tell it when it's okay and how much it's okay or not. So let's take a quick look at one of the demos that shows this feature in action. So this is the demo that you might already know. It's an older demo, but it shows the new features. So the old behavior was to simply keep the order. When there was a new element inserted, it could happen that, for example, if this one is new, that parts of the algorithm change because it's actually a new optimal drawing. But you might actually prefer to stay some unrelated or seemingly unrelated parts to have them stay at the original location. And that is what you can now do by telling it to keep the sketch. So when you insert an element, it will only change those items which already need to be changed, like in this case. You can take this one step further and tell it to use these exact coordinates. So even if I place them slightly off, it will only make sure that the minimum distances are kept. But you can, other than this, you can actually tell it to use different non-aligned versions of the sketch. So that's a new feature, and we hope that it will help your users to better keep their mental map of the diagram for incremental changes in the more complex cases. Another improvement that we did for the hierarchical layout was with respect to quality. So the hierarchical layout typically tries to come up with an optimal placement of the nodes. And optimal in the sense that it's a balanced layout. So as you can see in the diagram over here, this could sometimes result in a few very short segments, like we have it over here. And although it is, technically speaking, the more balanced layout, it introduces visual clutter. And now we optimize the algorithm to specifically detect and prevent those cases. So in the new version, you won't see small, shorter segments like we have here as often. So this is specifically done to deal with this, and it typically results in a clearer picture, easier to understand. And if you use edge labels, for example, it's easier for edge labels to get aligned because there's longer segments where you can place the labels. Also, a feature of the hierarchical layout was that you can specify sequence constraints, meaning that if you let the algorithm come up with a drawing for a graph, you could specify constraints between elements so that the order of the elements within a layer are realized exactly in the way that you want them to. In this example over here, we added constraints so that the nodes are in their alphabetical order. This typically doesn't result in an optimal drawing with respect to the number of crossings, because there's constraints that might enforce certain crossings, as we have in this example here. And previously, with the old implementation that we had, it could happen that if you add a lot of constraints, for those parts in the graph where there were no constraints, it could happen that they resulted in more crossings or in a less optimal solution. So since this is always just a heuristic, because this is actually an NP-hard problem and it's very hard to solve and would take a lot of time to solve perfectly, the old algorithm was not as good as the new one. So with a new algorithm, you should get far better results once you use sequence constraints a lot in your graphs. So here's another feature. That's another algorithm, and that is about edge routing. We always had this feature called bundled edge routing, which is typically used for graphs where you have fixed node locations. Like in this case, those are nodes on a map, on a geographical map. You might recognize the country over there. And specifically, if there's a lot of edges between those nodes, you typically end up with hairball graphs. And you want to somehow bundle those edges so that you see the main flows within the diagram. And that's where bundled edge routing comes in. The old algorithm that we had did quite well, but we found that there were some use cases that we could improve upon. And so the new implementation has, for one, it has a better performance. That is, it will work for larger graphs. And secondly, it also comes with a new option that specifically avoids edges crossing other nodes. Let's take a look at an example to see what I mean. This is the algorithm, and as you can see, this is the mode where we don't really try to avoid edges crossing other nodes, which is okay in certain scenarios. And it results in very nicely curved edge bundles. The new algorithm allows you to have better control over how straight those edges are, so how strong the bundling effect should be. So if you play with that, you get now a much more responsive behavior in the algorithm. So that's one improvement. The other improvement is that we actually implemented a way where the edges avoid the nodes, and this results in this. At the first sight, maybe more cluttered drawing, but if you look closely, you will find that the edges successfully avoid nodes and go around the nodes. So that's a really nice drawing in my case. It's not just edge bundling, it's also already an edge routing, because it really routes the edges across the graph. And again, you can determine let the algorithm determine how strong you want the bundling to be, or how closely you want it to follow the straight path or do all the curves. By the way, there's a nice color scheme that we have here, which really which you can take in and add to your graphs if you want to, if there's no color information in your graph, because this color scheme makes it easy to see bundles of different colors. You will see that in the circular layout, or in the single cycle layout, where without the color scheme, it's not easy to detect where bundles will go. And that color scheme, which is just a few lines of code in the demo, will apply a color scheme to the different edges in the bundles, so that different bundles get the same color. So it's much easier to follow where those bundles are going. So much for the bundled edge routing. Now let's go to what's new in the viewer. So that we now covered most of the bigger layout improvements. There are smaller ones in this release too, but these are the most important ones. But what's new on the viewer part? What's part of the visualization where it's really about rendering elements or interacting with the graph? The first feature is that we have a new type of shape supported by default in the library, and that's Squircles. Squircles are sit somewhere in between circles and squares, so it's not really a rounded rectangle, but it's this shape that you below here that you might know from your Android or iPhone screen, where the icons are rendered. These are Squircles. Why Squircles? Squircles are nice. They look nicer. They look less formal than rounded rectangles. However, they are more suitable for actually rendering text within when you compare that to an ellipse, for example, because they are much more space efficient than ellipses. So we added Squircles, which you could already do before with custom styles, but we added them to the core library. So if you use the styles that come out of the box with yFiles, you now get Squircles for node shapes, also for ports, and even for label backgrounds, and the text wrapping algorithm also supports Squircles. And all of this also works in WebGL, so you get all of the new features across the library and in the different rendering modes. That's it for Squircles. Another feature that you might recognize is something that we had before in some of our demos, and that's Heatmaps. Heatmaps are rendered behind graphs typically, and they can show some scalar values that are associated with nodes and edges. We had a similar feature as part of the demos in earlier versions of yFiles, but it wasn't part of the core. So it wasn't part of the library, but it was just demo code. And the reason was that this feature that we used a browser feature which wasn't available in Safari, and we didn't want to have that feature in the core library if it's not supporting the main browsers. So with this release, we actually re-implemented the heat map and made it to work with Safari, because it's now using WebGL, whereas before it was using SVG filters, which are not available in Safari. So this resulted in a cleaner implementation, in a supported implementation for our customers, because it's not part of the demo, but really supported part of the library. It gets a better performance and actually clearer visuals, specifically when you zoom into the graph. And it's super easy to integrate. So if you want them to integrate heat maps into your graphs, it's basically just 2.5 lines of code. So let's take a quick look at this feature. Here's an animated version of it. So this has really super good performance. When you run this, you can specify constant values for each element in your graph, or you can just like change those values over time, and then they will automatically update whenever you render. So these items, heat is supported on nodes and on edges, and there's some defaults that we have for different gradients. So if you don't like the default rainbow style, there's other settings that you can use, but you can also come up with your own gradients or shades. There's just some examples that we did for the demo. And as I said, if you zoom in, previously this resulted in the whole heat map becoming blurred. Now this works much better. So it's really like zooming along with the heat map, and all with really good performance with WebGL. So much for the heat maps. And another feature that we already had in the SVG rendering, but not in the WebGL rendering, is port rendering. So originally, when we came up with the idea of our WebGL rendering frontend, we envisioned that people would mostly be using it for really non-technical diagrams, like meshes, networks, where it's just like typically the round nodes with some straight edge connections. So we originally omitted a rendering of ports, and we didn't support the rendering of port visualizations within WebGL renderings, because that is a very technical aspect and most drawings don't need them. However, it turned out that some of you actually requested that feature and wanted to use port visualizations in their WebGL rendering. And this is what we did. Since with WebGL you don't get the option to easily implement your own styles, because this is all happening in shaders and low-level shader language. This is something that we had to add to the core library. And now, with a new version, you can use the shape port style default that allows you to add colored ports to your diagram in SVG. Now it also works with WebGL. At least for the majority of shapes. There's some less common shapes that we don't yet support in WebGL. Let us know if you require them too, but most people probably don't need a rotated star with eight peaks and things like that. So it's the most common ones like squircle, rectangle, circle, and triangle are supported, of course. So another feature that's available with WebGL, and which is also something that we found is something that you as a user want to use, is that due to WebGL being used for really large graphs typically, you typically need to zoom into the graphs to explore your graphs. Now, if you really start with a large graph with tens of thousands of nodes and then zoom in, or even millions of nodes and then zoom in, obviously you can't just like regularly scale a label or show all the elements at every zoom level. Just like when you use a tool like Google Maps, details will appear once you zoom in. And this is something that you could do with the old implementation already, but you had to do this manually. You had to like register a listener to the change of the zoom value in the graph component, and then adjust the styling or maybe toggle the visibility of elements. Now with a new version, this is built into the styling, and you can basically declaratively tell the engine when to show items depending on the zoom level and how to render them. And this is happening at the shader level, so there's no JavaScript involved here, so this gets super performant. So even with the largest graphs, where this is typically required, this should lead to super smooth performance. So there's two features that you can control. You can control visibility, meaning that you can declare at which zoom levels you want items to appear or disappear, and how you want them to appear or disappear. So you can like transition between those two states. So if once you cross a threshold between a certain zoom level, you can declare to it that then it will transition between a certain between being visible or invisible, and then it will change the opacity of the elements. And this works for nodes, for edges, and for labels, of course. And for labels, however, there's a second feature that we implemented that's really useful. Is if you really zoom in a lot into a diagram, well, obviously the font of a label should not really be zoomed along with the actual scaling level, because that would first result into very small text, or later on into super large text. So we made it possible to non-linearly scale the label text along with the zoom. You can declare how you want the label text to behave. So you can just have it stay fixed in view corners, so that just as you know it from like Google Maps. So if you zoom in, the text stays at the same size, but you can also tell it to slightly adjust with the zoom, or just be like linearly scaled with the zoom level. So this is where you start with a high-level overview of a simple graph, and there's no labels visible, but once you zoom in, you get to see more details. Labels appear, and if you zoom closer, more labels appear and more details appear up into this level. And you might see that when I change the zoom level, the size of the label stays the same for a certain amount of time. Only when I zoom in, at some point, they start to actually grow. And when I zoom even closer, they disappear again. So this is just a configuration that we did for this demo. You can do this on a per item level, meaning you can declare several levels of detail, and for each of them specify how you want them to behave with respect to the zoom level. So this really helps with navigating larger graphs. So next feature, which is not so much focusing on the graph itself, but on the interaction with the graph, is popovers. Popovers, you might not have heard that term before. Popovers are things like a context menu, or a tooltip, or additional a utility window. We had tooltips and context menus, of course, with yFiles, but with this release, we improved the features of the mechanisms that we offer. So there's a similar API in modern browsers available, and we modeled the new behavior to be very similar to this one, meaning those popovers can have new functionality. A popover is an element that is, in the case of yFiles for HTML, is any HTML content. So it doesn't have to be a graph, but it could be a graph. And typically, it will not zoom along with the graph, but it's anchored to an item. For example, in the case of a tooltip, you hover the mouse over an item, and then a popover appears. Typically, a tooltip is not interactive, meaning you can't click it or interact with it. But with this new popover implementation that we have, they can be interactive, and you can have multiple instances of them at the same time if you want. You have full control over where they are placed and how they react to changes. So you can implement things like moving popovers along with the mouse easily. You can control whether they will be rendered on top of the canvas like a tooltip, and what should happen when you pan the viewport, whether they should be rendered at the top level outside of the graph control or inside the graph component. And with this new feature, we also changed the way, as I said, how we implement tooltips, and we also changed and fine-tuned the defaults for tooltips. We took a good look at the different implementations of tooltips that are out there, and we tried to come up with the best defaults that we could find. So we found that there's certain behaviors that in older versions you had to reconfigure, and now we are pretty confident that the new implementation more closely matches your expectations. And let's take a look at this demo that shows the different possibilities that you get when you implement a popover, or a tooltip in this case. And at the core of this, these are all popovers. So the basic popover is just a tooltip. Of course, it can have any content. In this case, it's just a simple tooltip, and it appears once you hover over an item. Previously, once you moved the cursor, the tooltip would disappear. It now doesn't disappear by default anymore unless you move the mouse outside of the element. This is more in line with most of the tooltips that you will find out there, and is actually more helpful because small movements with the mouse don't discard a tooltip. You can control the placement of a node, of a tooltip. For example, in this case, the tooltip appears above the node. But you can also make the tooltip follow the pointer, like in this case. And as you can see here, you can update the tooltip content whenever you want, depending on external changes. For example, if it's showing live data, or in this case, when the mouse cursor changes. For example, we are showing the exact location on the node where the tooltip was triggered. Another option is to render tooltips somewhere else in the view. For example, in this case, anchored to the viewport at the bottom. And these options over here show more interactive popovers. There's two options where there can only ever be one, and they can actually coexist with tooltips, but they cannot coexist with other popovers. And there's also popovers that where you have full programmatic control over. So you need to determine when they close and where they open, and you can have as many of them as you want, obviously. And they can be interactive, and they can, well, influence your application. This was possible before, but it needed you needed to do some tricks and some special coding. And now there's a nice clean API for that, and you can just like copy out the parts from that demo that you like, those aspects, modify them to your needs, and apply them to your application. So much for tooltips. Let's take a look at what's new in yFiles for HTML 3.1, specifically for developers. For one, we updated our API docs. A few months ago, we already updated the documentation online. You might have seen that already. Now, if you haven't, please go and check them out. They really look nice. We implemented a fresh design and a focus mode where you can more easily read through the documentation. And we also dramatically improved the search user experience, so it's much easier to find new elements or documentation that you're looking for. This documentation viewer will also be part of the bundle when you download yFiles and run it locally, so you don't have to use the version on the website. On a more technical level, specifically for yFiles for HTML, we changed the way that the ECMAScript modules are treated at the lower level. So with this release, we are introducing a fine-grained module structure at the core, which you can ignore if you don't want to. But tools and bundling tools can use this to apply more efficient tree shaking. So if your application doesn't use all the layouts, all the features, maybe it doesn't use WebGL or GraphML, you can just rely on your build tool to tree shake those modules so that they won't be bundled into the application. Nowadays, application size isn't much of an issue anymore for sophisticated applications, specifically with the very good compression algorithms, and considering that most graphics are probably larger than the JavaScript that we deliver. But for those cases where you need full control over and the smallest possible library, this will help dramatically. Also, at the core, we increased the ECMAScript level of the core of the code that we ship in the library. So this also helped with the size. So we're using features like optional chaining operators, nullish coalescing operators, and so on, which actually result in smaller code, smaller JavaScript files. If you need to support older browsers, you can always use a bundler tool that transpiles this to older JavaScript. But typically, these are features that have been supported by browsers for a long time already. So last but not least, maybe it's for those who are already using yFiles, it's the most important change. Of course, we updated the demos again, and demos are not just showing what you can do with yFiles, they also serve as a repository for you to get ideas from and reuse code and add this to your applications. So the new demos that we have don't only just come with a new design. I hope you like it, and an improved reusability specifically for mobile devices. But we also have some really cool features packed into some demos that I would like to briefly show you that you might want to consider adding to your applications. So these are the new demos for the 3.1 release, and the first demo that I would like to show you is BioFabrics. It renders graphs in a way that that might seem new to you or maybe even unintuitive, but it massively helps with understanding graphs like this, which have a very dense structure where there's many edges connecting a node to other nodes. And basically, BioFabrics show you the same information in a matrix-like format. We have a whole webinar on this topic, so if you want to learn more about this, check out this webinar. The idea that I wanted to show you is that the source code of this demo is part of the package. So if you want to, you can just grab the piece of code, add this to your application, and if your users can benefit from a visualization like this, it's easy to integrate and add to your application. The other new demo that looks similar at first sight is the new event timeline demo. Event timeline is basically a bit like a horizontal UML sequence diagram. So you have actors or entities, like in this case there's some computer network and full stack entities involved, and they are rendered horizontally as across a horizontal timeline, showing when those elements interact with each other. So if your graph has timestamp data associated with it, you might be able to use this feature to give another view of your graph data to the user. The idea is to map the nodes to horizontal lanes and create edges at specific points of time according to the position on the x-axis. So this is time above here, and there's interactions happening between those elements at certain points of time, and you can zoom into the time to inspect elements which happen closely in time to each other. You can also just click it and it will zoom in, and then you see all the interactions between that happen at almost the same time. But in this case, it's happening within seconds. But there's also items that can happen really at the same time, where many elements are involved. And there's a nice view which shows this single point of time separated into different x values. This is just demo code, and it's using the new pop-up features, for example, and it's using the regular yFiles graph structure. So you can, if your edge data specifically has timestamps associated with it, you should be able to use this code and integrate that into your yFiles powered application. These are other demos that are new or showing new features of the release, and I would like to show you this one specifically. This is about Octilinear edge editing. Some of the yFiles layout algorithms support the creation of octilinearly routed edges, meaning edges that only consist of vertical, horizontal, or diagonal edge segments. And so this is not new. This is a layout, this is a hierarchical layout configured to show octilinear edges. But what you couldn't do before was to let the user interactively edit those diagrams conveniently, meaning that the user had to manually rearrange those bend points. And now this demo shows how you can dramatically improve the user experience. So edges will always stay octilinear, and you can even change like the amount that the octilinear part of an edge will be offset from the virtual corner point over here. So this is something that's part of a demo. So this is a customization on top of yFiles. And if you're using octilinear routing and want the user to be able to edit this, this is a cool feature that you can add to your application. The last demo I'm going to show you today is this one. It's a small feature that is interesting for you if you have like an editor-like application. And this one shows how to use the clipboard features of yFiles to copy styles or formats, as you may know that, for example, from an application like Word or PowerPoint, from one item to an existing other item. So, for example, if I copy the style of this node, I can apply it to that node over here. I can specify whether I want to apply the size or also the label positioning or not. And I can do this on multiple items at once. And again, this demo is using the Popover infrastructure that we have. And this is just showing how to use the clipboard facility in a creative way. So if you have a sophisticated editing application, this might be something that you can add to your application too. So there's other demos and new features, but I won't be going into details today into those demos. What we've seen so far is the new layout features. They will be coming to all yFiles versions, and we saw some WebGL improvements which are unique to yFiles for HTML, to the web platform. Also, the heat map rendering is exclusive to the web platform at this point. We saw popovers and tooltips, and this is something that you will also get in the other platforms, as well as the better documentation and new demos. And the good news is that if you're already on yFiles for HTML 3.0, migrating to 3.1 will be super easy, because it's going to be a drop-in replacement for probably like 99% of you. There are some incompatible changes where we provide you a migration guide and an automatic migration tool for, but more than 99.99% of the API has stayed exactly the same, and we only added new features. So it should be super easy for you to update your applications to work with version 3.1. When is that the case? You will be able to update to 3.1 by mid-May, meaning probably as early as maybe next week if you're lucky. And the corresponding versions and features will be coming to the other versions of yFiles, specifically to Avalonia, Windows Presentation Foundation, WinForms, and Java Swing. They will follow probably later this year. Maybe some of them will take more time, but they will all be coming to a version of yFiles. Okay, I think that's it. Check out the new demos online. The 3.1 demos for HTML are already online, and we'll be updating them one more time until the release, and then be sure to keep an eye out on the release next week for yFiles for HTML, and then later on for the other platforms. That's it from me. Thank you for listening. Have a great day, and goodbye. Happy diagramming.